Okay, so in the last couple of videos, we've been talking about the gravitational force. And just to recap really quickly some properties about the gravitational force, the concept is that all objects with mass experience an attractive gravitational force with all other objects that have mass in the universe. And that force gets bigger as the masses increase, or as the distance between the objects decreases. Okay, so in other words, the closer objects are, the stronger the force of gravity. The farther apart they are, the weaker the force of gravity. And that gravitational force is responsible for the orbits of the planets around the sun and the solar system around the galaxy and so on. It's responsible for the tides in the ocean and obviously, things falling down towards the ground, etc. And so we're going to move on to the next part of this unit, which has to do with electricity. And we're going to start this discussion by talking about charge. Okay, and so charge, or electrical charge, is an intrinsic property that some particles have that causes what's called an electric force between them. Okay, and so mass causes the gravitational force. Okay, we saw that in the equation for the force of gravity. It's charge that generates the electrical force. So in other words, there's only an electrical force between objects if those two objects have charge. And there's two types of charge that we've discovered over the last couple hundred years, and they were named by Benjamin Franklin a couple hundred years ago, and those two types of charge are called positive and negative. Okay, the names don't really mean anything. People get confused by positive or negative because they think of numbers, but really this is just something different. It doesn't really matter what you call them, but Franklin called them positive and negative, so we're stuck with that. Years later, after the electron was discovered, in the late 1800s, it was discovered that the electron has what's called a negative charge, and the proton has a positive charge. Okay, and so just to talk a little bit more about charge, you should have learned at some point in the past that all objects are made up of atoms. And there's different types of atoms. There's a whole periodic table showing you the different types of atoms. And each atom is made up of protons and electrons. And most atoms have an equal number of protons and electrons. But if you have an imbalance of protons and electrons, then that atom has a charge. It has an overall net charge. And so if you have an object made up of a bunch of atoms, and some of those atoms have an imbalance of charge, then the entire object is charged. And so very simply, if you have more positive charge than negative charge, the entire object is positive. And if you have more negative than positive, the object is negatively charged. Okay, if an object has the same amount of positive and negative charge, it's said to be neutral. Now, the electric force has a property that's a little bit different than the gravitational force. The gravitational force is always, always, always attractive. Okay, but there's two types of electricity. There's only one type of mass, but there's two types of charge. Okay, you have positive and negative. And so we've discovered through doing experiments that if you have two charged objects that are both positive, okay, so imagine you have, like, let's say, two balloons, okay, and you make one balloon positively charged. We'll talk about how you might do that later, but you can do that by like rubbing the balloon on your hair or on your clothes or something like that. And let's say you do the same thing to a second balloon. If you have two balloons and each one has a positive charge and you hold them next to each other, then those two balloons actually repel. Okay, they push apart. And you can look at demonstrations on YouTube showing this. Okay, but those two balloons would go apart. And it turns out if you have two balloons and you make each one have a negative charge, let's say these are negative charges, it turns out that they also repel. Okay, so in other words, if you have two objects that have the same type of charge, either both positive or both negative, those objects are going to feel a repulsive force. They're going to repel. They're going to push apart from each other. However, if you have one object that has a positive charge, and then one object that has a negative charge, it turns out that they actually attract. They actually pull together. They experience an attractive force. Okay, so gravity is always attractive, but the electric force can be either attractive or repulsive depending on the charge of the objects that you're talking about. If they're both positive or both negative, then they repel. If you've ever heard the expression opposites attract, a lot of people use that when talking about romance, but that saying opposites attract also applies to electricity. Okay, so positive and negative charge attracts. Okay, so moving on. Now you might ask, how do you charge an object? So we talked on the last slide about how an object becomes charged if there's an imbalance of protons and electrons. Now we now know, because now we know what atoms are made of, we now know that really when we talk about an imbalance of charge, what happens when an object becomes charged is either it gains electrons or it loses electrons. Okay, because if you think of like an atom, you have the protons and nucleus like stuck together in the center inside the nucleus, and then the electrons are on the outside. Okay, and so really an object cannot gain or lose protons because the protons are like wrapped up inside the nucleus, but they can gain or lose electrons. Okay, so if an object is just like out there and it gains extra electrons, that object is going to become negatively charged. And if the object loses electrons, it's going to become positively charged. And so we're going to talk about some different ways to transfer charge from one object to another. Okay, so in other words, we're going to talk about different ways that an object can become charged. And those three methods are charging by friction, by conduction, which involves direct contact, and by induction, which does not involve direct contact. Okay, and so we're going to talk about each of those methods of transferring charge here on the next slide, starting with friction. Okay, so when most people experience electricity on a daily basis, most of the way that people become charged is charging by friction. And the most common way this happens is just by rubbing two objects together. Okay, and so this could happen if you walk on the carpet, if you scrape your feet against the carpet. That's one way you can become charged. The act of rubbing two objects together transfers electrons from one object to another. So when you walk on the carpet, okay, that scraping scrapes electrons from the floor to your feet. If you gain extra electrons, that means your body becomes negatively charged. And then what can happen that probably most of you have experienced is if you like go to touch the doorknob or you're going to touch something metal, you might get a little shock. Okay, and so that's those extra electrons that are on your body transferring into the metal that you touch. Okay, and so most people might have experienced that before. You might have also experienced, like if you take off your sweater or take off like something made of wool, sometimes it sticks to your hair or it makes your hair like really frizzy, especially if you have like long hair. That basically involves a transfer of charge by friction, because when you pull the sweater up over your head, the inside of the sweater rubs against your hair, and so some of the electrons go from your hair to the sweater. Okay, what happens then is your hair is all positively charged, and so all the positive charge on your hair like repels, and so your hair becomes frizzy because it's trying to push apart, and it can really mess up your hair if you're not careful taking off the sweater. You might even notice sparks if you take off your sweater if it's cold outside, especially when it's cold outside. Sometimes I can hear like a little crackling in the air when I take off a sweater and I pull it up over my head. And so those sparks are, again, just the transfer of charge by friction just affecting the air. Okay, so those are the most common examples that people might be familiar with, like on a day-to-day basis. But you can also transfer charge by rubbing objects together, like rubbing a PVC pipe with an oven bag. If you take a balloon and you rub it on your shirt, okay, that is a transfer of charge by friction because that involves rubbing two objects together. Okay, so charging something by friction is probably the most common way of charging an object that you might experience day to day. Okay, so I'm going to link some videos in here so you can see what I'm talking about. Before we move on, by the way, I want to talk to you about an important object, and this object is called the electroscope. And normally I would show you this in class because we have some at school, but an electroscope looks kind of like this. You basically have like a sealed container made of glass or plastic, and you have a metal ball connected to a rod that goes into the bottle or into the jar. And at the bottom, you have what's called metal leaves. Okay, and so this device is called an electroscope. Now, the purpose of the electroscope is to detect charge. And so we'll talk about how it works, but basically what happens is if the leaves at the bottom, if they become charged, let's say the leaves become positively charged. Okay, so these are just two pieces of metal. Let's say this leaf becomes positive and this leaf becomes positive. If they're both positive, positive and positive repel, okay, because of the electrical force. We talked about that before. If both of the leaves become negative, the same thing is going to happen because negative and negative also repel. And so the electroscope is just like a really, really low-tech, simple device used to detect charge. Okay, so if there's charge on the electroscope, you actually see the little pieces of metal separate, and if there's no charge, then they go back together. Okay, so that's the only purpose of the electroscope, is to detect the presence of charge. Okay, so we talked about charging by friction. Now let's talk about charging by conduction and induction. Okay, the main difference between conduction and induction is that the transfer of charge by conduction involves direct contact between two objects. It says two conductors, but really just any two objects. Okay, so for example, I gave this example before, but when you scrape your feet on the carpet, okay, that is charging by friction. When you go to touch the doorknob, that's transfer of charge by conduction because you're actually touching the doorknob, which means those electrons on your body can jump into the metal doorknob. Okay, that's an example of charging by conduction. Another example would be like if you were to, let's say you take like a piece of metal and you charge up the piece of metal. If you poke somebody with it and shock them, that is a transfer of charge by conduction. Okay, so conduction involves direct contact. Induction does not involve the direct contact between two objects. Okay, so induction refers to the indirect transfer of charge, and I'll explain the difference between conduction and induction more on the next slide. You can see a picture. But induction basically works by taking an object that's charged and bringing it close to, but not touching, just close to, two conductors which are touching. And so then what happens is the charged object is going to repel the like charges into one of the two objects and attract the opposite charge into the original object. And so that might not make any sense, so let me explain with a picture. Okay, so here is a nice picture showing you induction at work. Okay, so let's say you have a rod, and let's say the rod has a positive charge. Why does it have a positive charge? I don't know. Maybe you rubbed it on your sweater, charged it by friction, whatever. And so let's say the rod has a positive charge. This is an electroscope. Okay, that's the metal ball, and these two lines at the bottom are the leaves. If you take this metal rod and bring it close to the electroscope, not touching but just close to, what's going to happen is if the rod is positive, then the electrons in the electroscope are going to want to be attracted to the rod. Okay, they want to get close to the rod because opposites attract. So that means the negative charge is going to end up at the top of the electroscope, and that's what you see here. You see the negative charge here in that circle. That's the top of the electroscope. Okay, but what happens if the electrons go up towards the top of the electroscope? That means the bottom at the bottom of the electroscope, because those electrons are gone, they went up to the top, at the bottom you just have positive charge. Okay, which means now I have positive charge in the leaves, and so what happens, the electroscope, the leaves repel. Okay, and so the electroscope activates. And so basically I've charged the electroscope by induction. I've got one side that's positive and one side that's negative. If I were to like take scissors and cut the electroscope like right here, I would have two charged objects, okay? Because the top half is negative and the bottom half is positive. Okay, that is charging with conduction. Sorry, not conduction, induction. Conduction involves direct contact. Okay, so this is what conduction might look like. Let's say you have the same positive rod. If you physically touch the electroscope, then the electrons can actually jump onto the rod, leave the electroscope completely, and then what happens is the electroscope has more positive charge than negative charge. Because if some of the electrons like left the building, they're not even there anymore. They're completely gone. They jump to the rod because of the direct contact. That means you have less electrons than you had before. That means now you have positive charge. Okay. So the key difference between induction and conduction is conduction involves direct contact. Induction, you're just taking something charged and bringing it close to a conductor. Okay, so those are the three methods of charging: friction, conduction, and induction. Okay, so let's take a look at this little picture. Does this represent charging by conduction or induction? Let me move this a little bit. Okay, so looking at this picture, conduction or induction? Well, it's kind of hard to see, but what you start off with is two metal balls, and they're both neutral because they have an equal amount of positive and negative charge. Then what happens is you can see down here, there's a rod that has a negative charge. Okay, so the negative charge in the rod repels the negative charge in the spheres, and so the negative charge goes to the left side, the positive charge stays to the right. But the key to answering this question is there's no direct contact between the rod and the spheres. Okay, so this is charging by induction just because there's no direct contact. You can see there's a gap right in there. Okay, so we have a charged object, but we're not, we're indirectly transferring charge through induction. Okay, so we've talked about charge, we've talked about the electroscope, we've talked about ways to transfer charge by friction, by conduction, by induction. I'm going to link some more videos in so you can see some demonstrations. Okay, and we're almost done with this video. The last thing I'm going to talk about in this video is what's called Coulomb's law. And Coulomb's law, so there's only two equations in this unit. Okay, there's Newton's law of gravitation, which we've seen before, and then there's Coulomb's law. Okay, and Coulomb's law looks very, very, very similar to Newton's law of gravitation. So Newton's law of gravitation looks like this. We have g times mass 1 times mass 2 divided by distance squared. Coulomb's law is the equation that gives us the electric force. Okay, so Fe, that is the electric force, is equal to K, where K is called the Coulomb constant. That is a constant whose value is about 9 times 10 to the power 9, times Q1 times Q2 divided by R squared. Now, R is the distance between Q1 and Q2. Okay, so what does that mean? Q is a symbol for charge. Okay, so M1 and M2, M is a symbol for mass, Q is a symbol for charge. The unit for charge is called the Coulomb. Okay, just like the unit for mass is called the kilogram. Now, Coulomb is named after a guy who is French. That's why you pronounce it like that. You don't say like Coulombs. Okay, it's Coulomb. It's French. Okay, that's also why it's a capital C, by the way, because it's named after a guy. So that's the unit for charge. And usually you see very small amounts of charge in problems because the Coulomb is a really, really big unit. Okay, and so the way this equation works is basically the exact same as Newton's law of gravitation, except instead of masses, you're dealing with charge. Okay, the other key difference, aside from the fact that obviously it's not the same constant because you don't have the gravitational constant, you have the Coulomb constant, and the value is different. But the other key difference is, remember, the electric force can either be attractive or repulsive depending on whether the charges are positive or negative, or one of each. Okay, so we're going to do just a few examples and then we'll be done with this video. Okay, this slide basically just talks about the difference between electric force and gravitational force. The electrical force is much stronger than the force of gravity, but we don't notice that very often because most objects in nature have an equal amount of positive and negative charge, and so they are neutral. The electrical force has to do with things like atoms and molecules, chemistry, and basically everything in chemistry has to do with the electrical force. The force of gravity affects objects like, the stars and the planets and the moons and the tides and bigger stuff like that. The gravitational force can only be attractive, whereas the electrical force can be either attractive or repulsive. Okay, remember, opposites attract, like charges repel. So positive and positive repel, negative and negative repel. Gravity has to do with mass. The electrical force has to do with charge. And obviously, the constants are different. The Coulomb constant is much bigger than the gravitational constant. Okay, so we're going to do two quick examples, then we will be done with this part of the unit. Okay, so example 1 says 2 pieces of iron are placed on a table at a distance of 0.02 meters apart. The first piece of iron has a charge of 2 times 10 to the negative 6 Coulomb. Remember, capital C, Coulomb. Okay, so that I'm going to call Q1 because Q is the symbol for charge. The second piece of iron has a charge of negative 4 times 10 to the negative 6 Coulomb. Okay, that capital C is Coulomb. I'm going to call that Q2. Now, the calculation is very straightforward because it's basically just like the last part of the unit. All you're doing is plugging numbers into an equation. Okay, so K is the Coulomb constant. That is 9 times 10 to the power 9. Make sure when you plug this in, you put parentheses around everything. Q1 is going to be 2 times 10. Somehow misspelled 10. 2 times 10 to the power negative 6. Q2 is going to be negative 4 times 10 to the power negative 6. Again, make sure you put parentheses around everything. And then we divide by the distance squared. Don't forget to square on the bottom. Okay, so 0.02 squared. All right, and you're going to plug this into the calculator just like this. Okay, so in my calculator, I am typing parentheses 9 times 10 to the power 9 times 2 times 10 to the negative 6 times negative 4 times 10 to the negative 6, and then divide by 0.02 squared. The number I get, see if you get this number, is 180 newtons. Or I guess specifically it would be negative 180 newtons. Now, is this force attractive or repulsive, and how do you know? Well, one charge is positive, one charge is negative. That means this force is attractive, and we know that because we have one positive charge and one negative charge. Okay, so that is it for example 1. Pause there if you need to look at that some more. Okay, one more example. I want you to try to do this one on your own. Please read this question carefully. So the problem says a proton inside a nucleus has a charge of 1.6 times 10 to the negative 19 Coulomb. I'm going to, and then it says in a helium atom there are 2 protons separated by a distance of 1.0 times 10 to the negative 15 meters. So that means if I have 2 protons, that means Q1 and Q2 are the same, and they're both equal to 1.6 times 10 to the negative 19 Coulomb. So I'm going to calculate the electrical force. That's K, Q1, Q2 divided by R squared. K is 9 times 10 to the power 9. That's the Coulomb constant. And then Q1 is 1.6 times 10 to the negative 19. Q2, 1.6 times 10 to the negative 19, because they're both the same, because I have 2 protons, divide by the distance between them squared. Again, make sure you put parentheses around everything. 1.0 times 10 to the negative 15, and then on the outside you put the square. Okay, so I'm plugging this into my calculator right now. The second question, by the way, as I type this into my calculator, the second question is asking if this force is attractive or repulsive. Well, if we have a proton that's positive and then another proton that's positive, two positive charges are going to repel. Okay, because positive and positive repel. And so this force is definitely going to be repulsive. And the force that you should get is a positive 230.4 newtons. That force is repulsive because positive and positive repel. Okay, that is it for the main part of this unit. Okay, hopefully you got that answer. As always, please let me know if you have any questions, and I'll see you guys in the next video.